Developing Algorithms with Arrays, Part 6. In this video, we will demonstrate how to determine if an array contains duplicate values. Consider the following array of integers. Suppose I want to determine if this array contains duplicate values or not. For this kind of problem, it'll be easier to understand if we illustrate how it'll work first before we code it. So, how will we start? We'll start by looking at the first value in the array, and we're going to call it our value of interest, or VOI for short. Why am I calling it that? Because we're going to determine if this value, the value at index 0, is duplicated somewhere else in the array. All right. So we're going to do that by first looking at the value after the VOI, which is the value at index 1, and we're going to compare them to see if they're equal. Since they're not, because clearly 4 and 30 are not equal, we're going to move to the next value and compare them to the VOI. Once again, not equal, so we're going to move on to index 3 and compare it to the VOI. Once again, not equal, so we move on to index 4 and compare it to the VOI. Not equal, on to index 5, compare it, not equal, on to index 6. We compare it again, not equal, and that completes one iteration of the array. So now we've at least determined that the value at index 0, number 4, is not duplicated anywhere else in the array. But that does not mean the job is done. We still need to determine if any of the other values are duplicated in the array or not. So now the value at index 1 is going to be our next VOI, our next value of interest. And now we're going to start comparing at index 2. Notice I'm not going to compare backwards. I don't need to compare the value at index 1 to the value at index 0 because we've already determined that the value at index 0 is not duplicated anywhere else. So there's no need to compare backwards. We're just going to compare forward. So we compare the value at index 1 to the value at index 2. They're not equal. So we move on to index 3. We compare. We see they're not equal. So we move on to the value at index 4. We compare. They're not equal. So we move on to the value at index 5. We compare. They're not equal. So we move on to the value at index 6. We compare. They're not equal. And that completes our second iteration of the array. Once again, now we've determined that the first two values are not duplicated anywhere else. Now the value index 2 will be our next VOI, our next value of interest. And once again, we only compare forward, not backwards, so we start at index 3. We compare the values at index 2 to the value at index 3. They're not equal, so we move on to index 4. Not equal, move on to index 5. Not equal, move on to index 6. Not equal, and that completes the third iteration of our array. Now the next VOI will be the value at index 3, 25. And once again, we compare forward. So we start comparing at index 4. Not equal, so we move on to index 5. Not equal, so we move on to index 6. We have found an equality. Thus, this array does contain duplicates. Now that we found a duplicate, we don't need to do any more iterations. We don't need to check any more VOIs. We're done because our objective was simply determine if the array contains at least one duplicate. Once we've found a duplicate, we've done all the searching that we need to do. Okay. So how will this program look like in coding? Well, the first step will be to declare a Boolean. We're going to call it found, and we're going to use this variable to store the final result of our work. When it's all said and done, if a duplicate was found, it'll be set equal to true. If a duplicate was never found, then it'll be equal to false at the end of a program. For now, we're going to initialize it to false. We're going to assume false until our searching proves otherwise. For the for loop, we're going to create it the way we generally create for loops because we want to look at every value in the array. Each value in the array could potentially be a value of interest at some point. So we're going to start by initializing I to 0 and incrementing by 1 all the way up until we reach the length of the array. Then, inside our for loop, we're going to pull out our VOI, our value of interest, which of course is the value at index I. We're going to take that value at index I and we're going to store it inside an integer called VOI. This is going to be our value of interest. Then, in order to compare the VOI to every other value after it in the array, we're going to use an inner for loop. We're going to create a for loop inside a for loop. And then for this for loop, since we've already declared a variable named I for the outer for loop, we can't declare a variable with the same name for the inner for loop. We have to use a different variable name. So we're going to say int j. And again, the purpose of this inner for loop is for the comparisons. It's for comparing the VOI to every other value after it. like we said during the illustration, we only compare forward, we don't compare backwards. So we're not going to start at 0. We're going to start j off at I plus 1, because once again, we're comparing forward. And then once we start at the value after the VOI, we're going to go from that point all the way up until the end of the array. So we're going to increment it by 1 up until we reach the length of the array. Then, inside the inner for loop, we're going to compare the VOI to the value index j to see if there's a duplicate. If they're equal, that means we have found a duplicate. Thus, we need to do two things. We need to set the found variable equal to true to indicate that we have found a duplicate. Then we're going to break from the inner for loop. Note that this break statement will only take us out of the inner for loop. It's not going to take us out of the outer for loop, only the inner one. That all being said, that's all we would need for the if statement and the for loop. Once the inner for loop is complete, what happens next is not as straightforward as you think. That's because what happens next depends on the reason we exited the for loop. Because remember, there's two possible reasons we could have exited the for loop. We either exited the inner for loop because we found a duplicate and thus broke out of it, or we exited the inner for loop because we checked every value in the array, we did all the comparisons, and we never found anything. We need to figure out why the for loop ended, because this will determine if we need to continue searching or not. So how do we determine the reason the for loop ended? By looking at the value of the found variable. If the found variable is equal to true, then that means we found a duplicate and we broke out of the inner for loop. If the found variable is not equal to true, then that means we simply did all the comparisons we could do and thus completed the for loop that way. So if found is equal to true and we did find a duplicate, then we're done searching, and thus we can then break out of the outer for loop, and which thus will end all the searching. If found is not equal to true, then nothing needs to be done. We're just going to continue iterating, moving on to the next VOI as we were. And that's all we will need for that if statement in the outer for loop. Once the outer for loop is finished, all that's left to do is to print out the final value of the found variable, which in this case, as we saw during the illustration, would be true since 25 is duplicated in the array.